Hello students, in this video I am going to explain or going to describe concepts related with hybridization. Hybridization topic I have selected from chapter Chemical Bonding, standard 11th class. If you see the question paper of NEET or JEE means advanced, then you find that there are some patterns, fixed pattern, and accordingly questions are being asked every year. So in this pattern, hybridization is also very important part. You will get question based on hybridization. So first I will explain how did concept of hybridization occur and how will we define hybridization, types of hybridization, then using combined effect of BSE-PR theory and hybridization to find shape of the given compound. So I am going to introduce hybridization. This topic I have selected from chapter Chemical Bonding. It is from Chemical Bonding, standard 11th class. But this hybridization part will be used, it can be used to find hybridization of both inorganic and organic compounds. Suppose questions may be asked, what is hybridization of PCl5? What is hybridization of XeF2? What is hybridization of CH3COOH, that is ethanoic acid? So we cannot avoid this part, these topics, because you will get many questions even in the board exam. Now patterns of questions has been changed. You are getting objective questions in the board exam as well. So here hybridization is very important. So first we should know how will we get the concept of, or how did we get the concept of hybridization. If you see the structure of carbon or atomic number of carbon, then you find that carbon has, its atomic number is 6 and it has 4 electrons in its as a valence shell. And if you take its electronic configuration, then you find that it has 2 electrons in the p subset last. So the earlier concept was that when there was no clear-cut idea about hybridization, the earlier concept was that total number of, this is very important concept I am giving, earlier concept or you can say old concept. What is old concept? So the number of bond can be made by an element is equal to total number of unpaired electron in its ground state. So if we see the ground state structure of the carbon, then outermost we will see only, we can write this also. Then you find that in 1s there are 2 electrons, in 2s there are 2 electrons. In chemistry language we will say it is full filled. There are words half filled orbitals, very important. That I will explain when I will go through atomic structure. So there is a word half filled or full orbitals. So for S subshell, half filled is 1 and full filled is 2. For P subshell, half filled is 3. Very, very important. P subshell has 3 p orbitals, px, py, pz. So there are 3 half fills. This is according to Hund's rules. We fill singly first. Then pairing will start. Fulfilled means maximum electron we can put in the P subshell is 6. First unpaired and then pairing. Similarly, for the D subshell, half filled is 5, fulfilled is 10. And for F subshell, half filled is 7, fulfilled is 40. So half filled and fulfilled orbitals are more stable than other orbitals. This concept you will get when you study atomic structure chapter. So here, if we see the electronic configuration in the ground state here, carbon is in the ground state, then you find that carbon has 3 orbitals, px, py, pz, but there are only 2 electrons in the P subshell. In the px, 1 electron, and in py, 1 electron. So if we take the concept, old concept, number of unpaired electron in ground state. Ground state is equal to bond making capacity, bond making form. So if we form the structure of carbon, then we find that carbon has only 2 valence electrons in the unpaired form, in the P subshell. So according to this old concept, carbon can make only 2 bonds. So if we see the structure of methane, then you find that carbon has 4 bonds. And according to old concept, total number of unpaired electrons in the ground state is the bond making capacity, is the bond forming capacity of element. So here this concept failed because unpaired electron is 2 and carbon can make 4 bonds. So we cannot take this concept. After that, another concept came that excited state. In the excited state, the number of unpaired electron is equal to total number of bond formed by that element. What is difference between ground state and excited state? In active form, when element is present, it is ground state. But when some energy must be given to excited, that is called excited states. So when energy is supplied to carbon, I have used star mark here to show excited state. So when some energy has been supplied, then we find that this is the configuration of carbon. Then we find that out of 2 electrons in S subshell, 1 electron will jump to pz orbitals. You can say S2s, this is px, this is py, this is pz. So from here we got the concept that carbon can make maximum 4 bonds. It has 4 unpaired electrons, so it can make 4. So if you see the structure of methane, then you find that here hydrogen is 1s, it is 2s. Here hydrogen is 1s, it is 2px. Here hydrogen is 1s, it is 2pyz. Here hydrogen is 1s, it is 2pz. So 4 different orbitals are used here. So the nature of bond must be different because 4 different orbitals are used. So again there is a contradiction, confusion, because here we observe that experimentally it has observed that all the 4 bond length of carbons are same and its bond angle is 109 degree 28 minutes. So again a new concept came that when any element is going to make compound, mind it, when an element is involved to form compound, then it's all pure orbitals, it's all pure unpaired orbitals intermixed together to form a equivalent orbital that is called hybrid orbitals. What I want to say here, carbon has 1 s orbitals and 3 p orbitals. All are unpaired, all are half filled. So when we will combine 1 s and 3 p, then we get 4 sp3 hybrid orbitals. So we can see that here the bond is not between s and s. We can say the bond is hybrid orbital sp3 and s. The bond is hybrid orbital sp3 and s. So all the bond, this is sp3, s, this is sp3, s, this is sp3, s, this is sp3, s. So all the orbitals, hybrid orbitals are same. So the type of bond will be same, bond length will be same, bond angle will be same. So this concept is known as hybridization. Hybridization is a process in which intermixing of pure orbitals takes place and the number of hybrid orbitals formed. Very, very important. You have 4 hybrid orbitals. It means 4 orbitals are mixed. If there is a 2 hybrid orbitals, then 2 orbitals are mixed. So we can say that hybridization is a process in which intermixing of 2 or more than 2 pure orbitals takes place in such a way so that energy is redistributed between the pure orbitals and equivalent hybrid orbitals are produced. So here this is the process of hybridization. So after getting the concept of hybridization, we came to conclusion that it is not pure orbitals used involved in the bonding, it is the hybrid orbitals that are used for the making of bond. That's why all the 4 bonds are equal, or 3 bonds are equal, or 5 bonds are equal, depending upon the types of bond, type of pure orbital mixed. So now I will explain how many types of hybridization nowadays we are using. So types of hybridization. There are normally we use 6 types of hybridization that we are going to use in standard 11 and standard 12 organic chemistry book. First is the here types of hybridization. First is that is very, very important, sp hybridization. Second is the sp2. Third is the sp3. Fourth is the sp3d. And sixth is the fifth is the sp3d. These hybridization concept we will use in physical chemistry standard 11 plus organic chemistry standard 11 and 12. Standard 11 organic chemistry. In organic chemistry we use standard 11 as well as 12. We have to find hybridization of the organic compounds like alcohol, ethanol, like chloroethane, like ethanamine, like ethanol. So here these only hybridization we will use. Apart from that we will use in inorganic chemistry also, that is inorganic compounds. When we will study P block, S block, D block, then P block compounds can also be showing this property. Apart from that, in standard 12 there is one chapter that is very, very important. This is called coordination compound. Very, very important. Coordination compound, or it is also called complex compound. In this chapter, sp3 and sp3d2. The types of hybridization: sp3, then dsp2, then sp3d2, and the last is d2sp3. So two new types of hybridization has been taken in this part: coordination compound or complex compound. That we will discuss when I will teach this chapter. What is coordination compound? How we will find its hybridization. But now I will explain, I will focus these 5 types of hybridization. What is sp hybridization? What is sp2 hybridization? What is sp3 hybridization? What is sp3d hybridization? What is sp3d2 hybridization? So you can explain here. Then one s and one p orbitals are used. Then two pure orbitals we have used. Then two hybrid orbitals we will get. That is sp. If one s and two p orbitals are used, then 3 sp2. If one s and 4 p orbitals are used, 3 p orbitals are used, that is 4 sp3. Here 1s, 3p plus 1d, that is 5 sp3d hybridization. And here 1s, 3p plus 2d, we will get 6 sp3d2 hybridization. So I will make an organized table, and in that table I will explain what is the bond angle of the given hybridization, what is its shape, and how will we find hybridization of the given compound as in the questions. So first we will make an organized table. So I am going to make an organized table to show the process of hybridization. Again I want to say that the hybridization are categorized into 2 parts. First is types of hybridization over their bond pairs are present, and second is types of hybridization when bond pairs and lone pairs both are present. So here I am just using only bond pair, no lone pair. So first, types of hybridization. Number of bonds, shape, bond angle, and example. One thing I want to say, the points related with hybridizations are: first point, the number of bond formed in a hybridization is equal to total number of orbitals used. Second, during the formation of hybridization, redistribution of energy takes place to find an stabilized state. So, first types of hybridization is sp. Here 1s and 1p are used. So we can say total number of bonds are 2. One example I can take like BCl2. This is the. So its shape is linear. Its bond angle is 180 degree. Example BH2, BCl2. Here one thing I want to say, this compound has not completed its octet. This is an exceptional compound that I have already explained in my previous video, chemical bond part, that some compounds are showing octet configuration, some compounds are showing duplet configuration, and some compounds are showing electron deficiency conditions, and some compounds are showing superoctet, that is more than 8 electrons in their outermost orbit. Second, sp2. Here one s and 2p orbitals are mixed. So 3, 2 sp. Here 3 sp2. I am using ammonia or BCl3. Boron trichloride. Here the bond angle will be 120 degree. Its examples are BF3, BCl3, NH4 plus, BCl3. Third one is sp3, 1s and 3p. So it is 4 sp3, 4 bonds are formed. Its example is methane. Its shape is planar. Here its bond angle is 109 degree 28, and so you can write 109 degree, and its shape is tetrahedral. Example, methane, NH4 plus, ammonium ion. Next, sp3d, 1s, 3p, 1d. Its example is phosphorus pentachloride, PCl5. Here the compound will showing more than 8 electrons in its outermost orbit. So here two types of bonds will develop. Here bond will be two types. And one very important question we get from this concept, from this part, I will explain. This bond is 90 degree and this bond is 120 degree. It is two types of bond angle and its shape is trigonal bipyramid. Trigonal bipyramid. One more compound, that is sp3d3. Here 1s, 3p and 2d. This is compound will be SF6. or its shape is octahedral. Bond angle 90 degree. It is SF6. Sulfur hexafluoride. So these are the hybridization that we have to study for the compounds of physical compounds, for the compounds of organic. With the example, I will show how these bonds are formed, how we will find the hybridization, what are the conditions required for this. But first you should understand that there are 6 types of hybridization normally we use. One is sp, sp2, sp3, sp3d and sp3d2. That is 5 different types of hybridization we will use for organic and inorganic compound. For coordination, 2 extra hybridization we will use. That I will discuss when I will teach coordination or complex compound. Now here, this part is very important. PCl5, there are 2 different types of bonds are formed. So I want to explain this compound. The questions ask that, these questions you take from NCERT. I have taken this question from NCERT book. This is NCERT book, just you will see. And this question is given in NCERT. Describe the hybridization in case of PCl5. Why are the axial bonds longer as compared to equatorial bond? This question I have taken from Chemical Bonding and Molecular Structure Standard 11 book, and this question is very important that you have to explain hybridization of PCl5 and you have to explain types of bond that will develop in PCl5. If you see the structure of PCl5, then you find that in PCl5, 2 different types of bonds will develop. There are 2 different types of bond develop. This is phosphorus. 5 Cls are there. First you just draw the dot structure. So I am using only 1 electron of chlorine. Phosphorus has 5 electrons. So if you see the dot structure of, I am not using the outermost electron of chlorine. That I have already explained in my previous video. It is when we are going to make questions based on competition, time factor is very important. So no need to show this part, only you need to understand that how many types of bonds will develop. So here 5 bonds are there. So 3 bonds will arrange like this. This bond is known as equatorial bond and it will make an angle of 120 degree. This bond is called equatorial bond. Two extra bonds here, that is perpendicular to it. This bond is known as axial bond. Axial bond. And its angle is 90 degree. So you can say that for the formation of PCl5, we need 2 types of bond. One is the axial bond and second is the equatorial bond. Now, if we see the here structure, to avoid, this is here the chlorine has 6 electrons. This chlorine also has 6 electrons as a valence electron. To avoid repulsion between these 2 atoms or electrons, what happens? This bond becomes elongates. It becomes a little bit longer. So you can see that axial bond is longer than equatorial bond because it avoids repulsion between electron-electron pair. So in this way, we can say that how will we can form bond in PCl5. This is the types of bond that is developed in PCl5. Now we have to explain the types of hybridization, some examples of organic and some examples of inorganic compound. Suppose you have to find hybridization of NH4 plus, that is ammonium ion, BCl3, that is boron trichloride, C2H4, that is ethine, C2H2, that is ethene, that is organic compound, and one more example we can take, CH3COOH. So when you are going to show the hybridization of organic compounds, then for organic compounds we will find a hybridization of each carbon. And for the formation of hybridization, we should know the dot structure, Lewis dot formation of the given compound. So ammonium, I have already explained how the bond developed. You can see my video, the previous video based on chemical bonding. There is a coordinate bond formation. So you have 4 bonds, so its hybridization is sp3. BCl3 is a structural compound, I have already explained. One example, C2H4, that is 2 carbon and each carbon will carry 2 hydrogen. That I have already explained in my previous video, but again I want to remind you that how we will pick. I have already explained the number of bonds present inside the 2 atoms must be equal to number of electrons required to fulfill octet. So here, this is the duplet, this is the duplet, this is the octet of carbon. This is the duplet, this is the duplet, this is the octet of carbon. So you can say that carbon-carbon double bond and 2 hydrogen. So for each carbon, here 3 bonds are there. Out of 2 bonds, one is sigma, one is pi. Again the important things, you can calculate hybridization either in terms of sigma bond or in terms of pi bond. I have taken on the basis of sigma bond. If there are 3 sigma bond, if there are 4 sigma bond, if there are 2 sigma bond, here each carbon has 3 sigma bond, so it is sp2. This is sp2. In ethine, dot structure I have already shown. Each carbon has 2 sigma bond. This is sigma, sigma, sigma. The rest are pi. So it is sp. This is sp. And in ethanoic acid, each carbon, this is the bond. This carbon has sp3 hybridization and this carbon has sp2 hybridization. So in this way, we can calculate hybridization. There are many questions given in the book related with hybridization. There is one question I want to explain. Draw a diagram showing the formation of double bond and triple bond between carbon atom of C2H4 and C2H2. Very, very important. These 2 bonds I have already drawn. But there is a question, how will you explain this? How will you explain bond formation in double bond or triple bond compound, that is ethene and ethine? So, in order to explain this structure, we need to know that sigma bond I have already explained in my previous video, but again I want to remind you, sigma bond formation takes place when there is a end-to-end overlapping, whereas pi bond formation takes place lateral overlapping. So first, in order to show bond formation in ethine and ethene, we should know the differences between sigma bond and pi bond first. Then we can explain the structure of C2H2 and C2H4. So I want to explain this using a proper diagram. So पहले हम लोग first we will see the differences between sigma bond and pi bond. Sigma bond and pi bond. You can say it is a strong bond, first difference. This is a weak bond. Second, end-to-end overlapping. This always takes place end-to-end overlapping, that is maximum overlapping. When there is a maximum overlapping like s orbitals and p orbitals, this type of hybridization, this type of sigma bond, suppose px and s. Here, side to side overlapping. Yeah, you can say lateral overlapping. Like this. Electrons are there, suppose one electrons are there. Here, electrons. Third, always exists singly. And without sigma bond, we cannot imaging bond. So it is present everywhere. It is present everywhere. Here, may or may not present. May or may not. We can imaging a compound without pi bond, or we can imaging a compound with pi bond. It may or may not present. And it may be singly or in pair, but it will never exist in pair. So if you see the structure of C2H4, first I will say C2H4. See, here sp hybridizations are used. That is, 1s and 2p orbitals are used to make 3sp2 hybridization. So 1p orbitals remain unutilized, remains vacant. I am writing this like this so that you will understand it easily. Here, 1p orbitals that are not used in hybridization, that will lie parallel to each other and they overlap laterally and they form. See, this is the single bond due to hybridization, and this extra bond developed between them, that is why. If we see the structure of ethine, then in ethine, each carbon has 2 bonds only. Here 2 bonds, each carbon. So 2 orbitals, py and pz. Py and pz remains unoccupied. So py overlap with pi and pz overlap with pz. You can show pz here. So py overlapping produce 1 pi bond, and pz overlapping will produce next extra pi bond. So 2 extra pi bond formation takes place. So if you compare methane, carbon in methane, carbon in ethine and carbon in ethene, then you find that in methane all the 4 orbitals are used. 1s and 3p. So 4 bonds will develop. All the 4 bonds are single bond. That is sigma bond. But in ethene, 3 orbitals are only used. 1 orbitals are not used. That will form 1 pi bond. Whereas in ethine, only 2 orbitals, 1s and 1px are used. Py and pz orbitals are not used. so they form 2 extra pi bond. In this way, we can see the bond formation types of hybridization in these compounds. So I hope the concept, the information that I have given related with hybridization is beneficial for you. It is going to be useful for you. You will take advantage of that to understand this topic. In the next video, I will explain how we make hybridization of coordination compound. First, I will explain coordination compound and their hybridization in detail. Thank you.